So in this case, we are given a parabolic function of which the equation is unknown and an exponential function with the equation g of x equals 1/2 raised to the x minus 4. Now, a and b are the x-intercepts of f, and the two graphs intersect at A. The point E, it's just the point that lies on the function of f. And then they say C is the turning point of f, and D is the y-intercept of G. This is what we have. So let's give the sketch a good look. Do you see that? Awesome. Now, the first thing we realize, if we look at the exponential function, the -4 there is the horizontal asymptote. So we go and label it as y equals -4. Then the first question says, write down the coordinates of D. So we said D is actually the y-intercept of the exponential function. So we said in order for us to find the y-intercept, we have to let x to be 0. Now, any number to the power 0 is 1, and 1 minus 4 is -3. So this means the coordinates of D will be where x is 0, y is -3. Right. Then the second question says, write down the range of G. So what is the range in simple language? It's just where the function starts in terms of y values and where it ends. So if you look at this exponential function, you can see that in terms of y values, it starts at -4 because you don't have the graph anywhere below -4. Do you see that? So it starts at -4, but where does it end? So if you look at this arrow, it tells you that the function keeps going up in terms of y values. So this means the range will be from -4 all the way to +infinity. That is your range. So you'll say the range of this function, y is an element of all the values from -4, sorry about that, to +infinity. Now the question is, why are we not including -4? It's because at exactly -4, the function is undefined at the horizontal asymptote. That's what we know. Yes. And yeah, this is the alternative notation which you can use when stating your range. Fine stuff. If we look at 5.2.1, it says, calculate the coordinates of point A. So the point A is the point of intersection for both of these graphs. We could be using the parabolic function, but we don't have the equation for it. So it means we have to use the exponential function. So the point A is the x-intercept of the exponential function. So what is happening at the x-intercept? It's where y equals 0. Do you see that? Then you just have to solve for x. Now, the first thing you do, you take -4 to the left, so it becomes positive. Do you see that? But now you realize this is actually an exponential equation, and you can't solve for an exponential equation at your age if the bases are not the same. So the first thing you have to do is to make sure that the bases are the same. Now, we are going to write 4 to base 2. So it becomes 2 squared. And then this 1/2, we write it in negative exponential form as 2 to the -1. And then the whole thing is raised to the power x. Then you multiply the two exponents, you get 2 to the negative x. The bases are now the same, so then we equate the exponents. Dividing both sides by -1, it means the value of x will just be -2. But because it's the x-intercept, then you'll say the coordinates of point A is where x is -2, y will simply be 0. And then you are happy. Awesome. Then the next question says, calculate the values of A and Q. So in other words, they are saying, determine the equation of the parabolic function. Do you see that? Right. Now, because we don't know what is the value of C, no, let's not say that. So what are we going to do here? Well, we state the equation. It's f of x equals ax squared. And then you say plus q. So the first thing we do, we substitute the x-intercept, which is point A. So you say you have A into x is -2, you square this and add q, and then your y will be 0 when x is -2, right? Awesome. Then here you'll just have 0, which is equal to what? -2 squared is 4. 4 times A, it's 4A. And then you say plus Q. So if you were to make Q the subject of the formula, you just take 4A to the left. Then you realize your Q will just be -4A. Okay, fine. We still haven't solved anything, right? Now you come back and remember that the point E lies on the function as well. So you substitute the point E into this equation. So you say the y value is 3 when x is 1. And then you say plus q. Now 1 squared is 1 times A is A. So it means you have 3 equals A plus q. If you want to make q the subject again, you'll just say q will be 3 minus A. Oh, so now you realize you have two equations, each with two different unknowns. Do you see that? Not really different, right? And then what do you say from this point? Well, you equate the two functions, or rather the two equations, because both of them are equal to q. So you say -4A equals 3 minus A. Of course, you could have done it the other way, right? There are many ways to kill a cat, especially for simultaneous equations. Then you take this -A to the left, it becomes positive. -4A plus A, you get -3A, which is equal to 3. And therefore, the value of A here will just be -1. And this is true because A is the coefficient of x squared. And we said if A is negative, the function is facing down, which is what we see in this case. Right. So now that we have the value of A, how then do we find the value of Q? Well, you can substitute the value of A into either equation 1 or equation 2, whichever one you prefer. But let's go to equation 3. So you'll say your Q equals 3 minus -1. And this will just give you 4. So the value of A is -1. The value of Q is +4. Are you fine? Right. And what is Q? Q is just the y-intercept. So this means the coordinates of point C will just be 0, and 4. And then your happiness is complete for this question. Now the next question says, determine the length of CD. Do you see that? Now, if you look at the sketch, you realize that CD, it's just a vertical line. And if you must calculate the length of a vertical line, you only consider y values. So you say the bigger y value minus the smaller y value. That's how you do it. So what is the bigger y value in this case? It's positive 4. And the smaller y value, it's negative 3. Yes, that's how you find the length of CD. You say the y value at C minus the y value at D. So here the y value is 4, but here the y value is negative 3. So 4 plus 3 will just be 7 units. Very key. Very, very, very key. Fine. And then they say, determine the equation of a straight line through A and D. So that's what they tell us. So apparently, there's going to be a straight line that passes through A and D. So let's assume it's a straight line. Now, if you must find the equation of a straight line, you only need 2 things, right? You need to know the gradient of that line and 1 point through which the line passes so that you can find the y-intercept of that line. Now, let's start first by calculating the gradient. So you'll say the gradient is y2 minus y1 divided by x2 minus x1. So let's say you choose point A to be 1. So meaning it's x1, y1. And then the point D to be 2, x2, y2. So we said the coordinates here is 2 and 0, negative 2, sorry. And then the coordinates at point D, it's 0 and negative 3, right? So you say y2 is negative 3 minus y1, which is 0. And then you say x2 will just be 0 minus x1, negative 2. So it means the gradient will just be negative 3/2. Do you see that? So once you know your gradient, then you have to substitute either point A or point D in order to find the y-intercept of the straight line. So let's write the standard form for a straight line. You can say y equals mx plus c or y equals ax plus q. It's up to you. Now the gradient we calculated as negative 3/2. Let's substitute point D. So at point D, we say the x value is 0 when the y value is negative 3. Do you see that? So negative 3/2 times 0 will just be 0. So this means your C will simply be negative 3. So this means the equation of this line, it's just going to be y equals negative 3/2x minus 3. Yes. And then you are set once again. Now we get to the questions which are nice, just that people choose not to appreciate them. But seeing how you are listening to me, watching this video, so I know you'll appreciate these questions, the inequality questions. They are nice, guys. Now the first one says, for which values of x is f of x greater than 0? So how do you interpret this? When they say f of x is greater than 0, they mean the y values on the function of f are positive. So we are looking for the values of x. That will make sure that the y values on the function of f are positive. And where the y values are positive, it's where the function is above the x-axis. Do you see that? It's not bad. So let's go and identify that. Now, if we look at this sketch of ours, this is f of x. Do you see that? And we can see that the function is above the x-axis between the x-intercepts. Do you see that? So between a and b, your function is above the x-axis. So that is where f of x is positive. Now, if you know that the x-coordinate here is -2, you already know that the x-coordinate there will be +2, because at your age, the x-intercepts will always be the same. They'll just be opposite inside at your age. Fine stuff. So this means the function will be above the x-axis, where x is between 2 and -2. So we don't include -2 and +2. Why? Because these are the x-intercepts. And at the x-intercepts, it's where the y values are 0. Do you see that? So you can write it in the inequality notation, or you can say it's all the values of x from -2 to 2. This is where the function is above the x-axis. But what if they asked you, where is the function below the x-axis? For which values of x is f of x less than 0? What are you going to say? Well, you can see that because the function is continuous, in terms of values of x, from -infinity all the way to -2, the function is below the x-axis. But that's not the only place. From +2 all the way to infinity, we can see that the function is below the x-axis. So you say f of x is less than 0, where x is less than -2, or where x is greater than 2. This is how you could have said it. Alternatively, you could have said it's any value of x from -infinity to -2 in union with all the values from 2 all the way to infinity. Do you see that? Right. And then the last question says, for which values of x is f decreasing? So if they say decreasing or increasing, you have to go to the x-coordinate of the turning point. Then you want to see what is happening to the graph on either side of the x-coordinate of the turning point. So let's see. The x-coordinate of the turning point at your age will always be x equals 0. So if you look at this function on the left of 0, meaning from -infinity to 0, you can see that your function is increasing. Do you see that? But if you focus on the right of 0, you can see that your function is decreasing. So what am I saying? What am I saying in short? I'm saying to you, your function will increase for any value of x that is greater than 0. Did I say increase? No, I wanted to say decrease. Sorry about that. Yes, your function decreases for any value of x that is greater than 0. Alternatively, you can say it decreases for any value of x from 0 all the way to positive infinity. And then you should be happy for this one. Yes, so I think this should be the end of this video. I really hope you enjoyed it. And if it did, please make sure you subscribe to our channel and please give this video a thumbs up. But thank you so much for watching. Let's see you in the next one.